For lesson 5 in unit 10, we're going to look at secant lines and segments in circles. We're going to deal with some awesome angles formed along with the lengths of partial secant lines and as they interact with the tangent segments as well. So this will be kind of an interesting thing where we might mix up the recipes a little bit, and so I want to make sure that we do a good job of kind of laying this groundwork. I'm going to have you finish some of the algebra tonight, and then we'll touch base in class when we work together. So a secant line is a line that intersects the circle in exactly 2 points. So we have a chord, and this is the segment that's inside the circle with the endpoints on the arc that it intercepts. But a secant line extends outside of and beyond the circle. So a secant ray would go from like A past B or B past A. This whole segment with these points outside of the circle would be a secant segment. The whole line would be a secant line. And the measure of an angle formed when two secants intersect is going to be found by taking half of the sum of their intersected arcs. So the measure of angle 1 here would be the sum of these two arcs divided by 2, or half of this sum. If I were to find the measure for angle 2, we would have to look at arc A and B, and we would say the measure of angle 2 would be half of arc A and B added together, knowing that these need to add up to 180, right? And so we have that limitation where we can use vertical angles to know that we have angle 1 and angle 1, angle 2 and angle 2. We've got supplementary angles along the way as well. So synthesizing some of those ideas from even first semester in our work here now. And so there is also an extension where what if these secants intersect inside the circle? That's the relationship. But if they intersect outside of the circle, it may look like this. And so here, we're going to find that the measure of this angle is half of the difference, the big one minus the small one. Half of the difference, the big one minus the small one. Half of the difference, the far one minus the close one, right? The big one minus the small one. It's the same recipe. It just looks like separate cases, but basically if that point of intersection is outside of the circle, it's going to be half of the difference. So we're going to have to do some subtraction instead of the sum of, all right, when we are inside. So for this, again, I'll write the equations. Your job is going to be to solve them. But to find x, we are going to take half of the measures of these arcs added together. So you go ahead and finish. You solve for x there. Taking x is half of the measure of those arcs added together. Over here, the angle, and this one's a little bit tricky, this one intersects outside of the circle, and we know the angle measure, so the work that we're going to do is like solving an equation, whereas this is just evaluating. Type that in your calculator, you'll have the answer. Over here, it's a little bit different because this 20 degrees is going to be half of the difference of the far arc minus the close arc. And so your job is to solve for z. 20 is equal to 1/2 times 95 minus z. All right? Solve that equation doing your Algebra 1. We'll obviously check our answers in class. For the next piece, so that was angle measures. Now we're talking about segment lengths. And so obviously this segment has its full length. All right, this has the full length P and Q added together. This full length M and N added together. This full length is C and D added. This full length is A and B added. But where the intersection happens is going to dictate how we write our equation. Here, we're going to say that if it's inside the circle, then we have the product of the parts of the segments are going to equal each other. So A times B is going to equal C times D. If the parts, if those segments intersect outside of the circle, where we have two secant lines or a secant and a tangent, the formula is going to be a little bit different, all right, between these two. Here, we're going to take the full length multiplied by the part that's outside. Here, the full length multiplied by the part that's outside. All right, it's the same idea here, except for the part that's outside is the full length on that tangent segment, right? So the full length, y and z added together, times the part that's outside, is going to equal the full length x times the part that's outside, right, which is x. So we get x times x. So keeping those straight is going to be, obviously that's what we're learning about. That's what we're going to struggle with, wrestle with, but we're going to practice it at length so that we do a good job with it, you know, obviously in class, but then again on exam day and review day. So here, the way that we're going to set this up, these are intersecting outside of the circle. So we will have the full length, 6 plus 8, multiplied by the part outside of the circle, which is 6. That will equal this whole thing, which is 7 plus y, multiplied by the part, whoops, that's outside of the circle, which is 7. You can solve that equation doing algebra 1. You need to solve this one. All right, over here, the full length, 16 plus 8, multiplied by the part that's outside, 8, is going to equal the full length times the part that's outside, which is the same, z times z, so we get z squared. Go ahead and do your best to solve that equation. If you need to write that in simplest radical form, then do that in simplest radical form. But that's it. And so we have this great summary on the last slide that kind of can help you keep things straight. You finish all that algebra, you solve all those equations. All right, and I don't want you to think of this as too many different situations, but it's going to require us to think a little bit about it. When there's inside versus when there's outside, all right? When there's inside, it is half the sum of the intersected arcs. When it's outside, the measure of that angle is half the difference of the far arc minus the close arc. All right, the far arc minus the close arc. When we are talking about segment lengths, if it intersects inside, it's the parts multiplied equal the parts multiplied. If they're intersecting outside of the circle, then it's going to be the whole thing times the part outside the circle. The whole thing times the part outside the circle. This one looks different, but it's still the whole thing times the part outside the circle is equal to the whole thing times the part outside the circle. It just happens to be the same number there. And so that's why that one shows it squared. Don't think of them as different though, they're really the same thing. So this isn't 1, 2, 3, 4, 5, 6, 7 things, it's 4 things. And so if we can keep those things straight, we should do an awesome job. Please let me know what questions, if any, you have.